Arc fault circuit interrupters, or AFCIs, are not solely mandated for bedrooms. The National Electrical Code, or NEC, requires them in numerous other areas. These areas include family rooms, dining rooms, living rooms, parlors, libraries, dens, sunrooms, recreation rooms, closets, hallways, and similar rooms or areas. The rationale behind not requiring AFCIs in every area of a dwelling stems from a risk assessment related to arc fault occurrences. Areas designated for sleeping purposes present a heightened risk profile compared to other spaces within a residence. Arc faults tend to manifest more frequently in environments characterized by substantial movement and activity. Bedrooms, for instance, witness frequent activity as occupants enter and exit beds, potentially stressing electrical cords and wiring. Similarly, living rooms often involve movement of furniture and engagement with various electronic devices and toys, increasing the probability of cord or wire damage leading to arc faults. Conversely, areas with less dynamic activity, such as kitchens and bathrooms, exhibit a comparatively reduced risk of arc faults. These spaces typically feature fewer electrical cords and wires, minimizing the likelihood of damage-induced arcing. It is crucial to acknowledge that while the NEC requirements target specific areas, arc faults can theoretically occur anywhere within a residential structure. Consequently, adopting a comprehensive approach by installing AFCIs throughout the entire home offers an enhanced level of electrical safety and protection. AFCIs are designed to detect arc faults, which are dangerous electrical conditions that can cause fires. Unlike traditional circuit breakers, which primarily respond to overloads and short circuits, AFCIs are specifically engineered to identify and interrupt arc faults. An arc fault occurs when electricity jumps, or arcs, between two conductors, creating intense heat that can ignite nearby materials. Common causes of arc faults include damaged wiring, loose connections, and frayed cords. There are two main types of AFCIs: branch or combination AFCIs and outlet branch circuit AFCIs. Branch or combination AFCIs offer protection for the entire branch circuit, including the wiring and devices connected to it. Outlet branch circuit AFCIs are installed at the outlet and provide protection only for that specific outlet and downstream wiring. The NEC mandates the use of combination type AFCIs for new installations and when replacing existing AFCIs. AFCIs work by monitoring the electrical current for unusual patterns that indicate an arc fault. They use sophisticated electronics to distinguish between normal arcing, such as that produced by a light switch, and dangerous arcing that could start a fire. When an AFCI detects an arc fault, it quickly trips the circuit, cutting off the flow of electricity and preventing a fire from starting. The installation of AFCIs is similar to that of standard circuit breakers or outlets. However, due to the sensitive nature of the technology, it is crucial to follow the manufacturer's instructions carefully. Incorrect installation can lead to nuisance tripping or, more seriously, a failure to detect and interrupt arc faults. When selecting AFCIs, ensure they are listed by a recognized testing laboratory, such as Underwriters Laboratories, or ALL, to verify their safety and performance. The listing mark indicates that the AFCI has been tested and meets established safety standards. Regular testing of AFCIs is essential to ensure they are functioning correctly. Most AFCIs have a test button that simulates an arc fault and trips the circuit. It is recommended to test AFCIs monthly to verify their proper operation. If an AFCI fails to trip when the test button is pressed, it should be replaced immediately. While AFCIs provide significant protection against arc faults, they are not a substitute for other electrical safety measures. Proper wiring practices, regular inspection of electrical cords and devices, and the use of surge protectors are all important components of a comprehensive electrical safety plan. Furthermore, it is crucial to address any known electrical hazards promptly. If you notice flickering lights, sparking outlets, or other signs of electrical problems, consult a qualified electrician to investigate and repair the issue. In addition to AFCIs, ground fault circuit interrupters, or GFCIs, are another important safety device used in homes. GFCIs protect against ground faults, which occur when electricity flows through an unintended path to ground. Ground faults can happen when a person comes into contact with a live wire or a faulty appliance. GFCIs are typically required in areas where water is present, such as bathrooms, kitchens, and outdoor outlets. They work by monitoring the current flowing to and from an electrical device. If there is a difference of even a few milliamperes between the two currents, a GFCI quickly trips the circuit, cutting off the flow of electricity and preventing electrical shock. While AFCIs and GFCIs both protect against electrical hazards, they address different types of faults. AFCIs protect against arc faults, which can cause fires, while GFCIs protect against ground faults, which can cause electrical shock. In some cases, both AFCI and GFCI protection may be required in the same location. For example, the NEC requires both AFCI and GFCI protection for certain outlets in bathrooms and kitchens. In these areas, the combination of AFCI and GFCI protection provides the highest level of electrical safety. Understanding the differences between AFCIs and GFCIs and knowing what they are required is essential for ensuring the safety of your home's electrical system. If you have any questions about AFCIs, GFCIs, or other electrical safety matters, consult a qualified electrician. An electrician can assess your home's electrical system, identify potential hazards, and recommend appropriate safety measures. They can also install AFCIs and GFCIs correctly and ensure they are functioning properly. Electrical safety is a critical aspect of home ownership. By taking proactive steps to protect your home from electrical hazards, you can significantly reduce the risk of fire and electrical shock. This includes installing AFCIs and GFCIs where required, following proper wiring practices, and addressing any electrical problems promptly. Remember, when working with electricity, safety should always be your top priority. The National Electrical Code, or NEC, is a comprehensive set of standards for electrical wiring and equipment in the United States. It is developed and updated every 3 years by the National Fire Protection Association, or NFPA. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is used by electricians, inspectors, and other professionals to ensure the safe and proper installation of electrical systems. The NEC is not a law itself, but it is often adopted by state and local jurisdictions as part of their building codes. This means that compliance with the NEC is legally required in many areas. The NEC is organized into chapters, articles, and sections. Chapter 1 contains general requirements that apply to all electrical installations. Chapters 2 through 7 cover specific types of installations, such as wiring methods, equipment, and special occupancies. Chapter 8 covers communications systems, and Chapter 9 contains tables and examples. The NEC is a complex document, and it can be challenging to understand for those who are not familiar with electrical terminology and concepts. However, it is an essential resource for anyone involved in the design, installation, or inspection of electrical systems. Electricians must be licensed in most jurisdictions. Licensing requirements vary by state and locality, but typically include a combination of education, experience, and examination. Licensed electricians have demonstrated their knowledge and skills in electrical work and are qualified to perform electrical installations safely and in accordance with the NEC. When hiring an electrician, it is important to verify that they are licensed and insured. This will protect you from liability if something goes wrong during the electrical work. It is also a good idea to get multiple quotes from different electricians before making a decision. Be sure to ask for references and check online reviews to get an idea of the electrician's reputation. Electrical work can be dangerous, so it is always best to hire a qualified professional. Attempting to perform electrical work yourself without the proper training and experience can put yourself and others at risk of injury or death. In addition to AFCIs and GFCIs, surge protectors are another important safety device for protecting electronic equipment from damage caused by voltage surges. Voltage surges can occur due to lightning strikes, power outages, or other electrical disturbances. They can damage sensitive electronic components in computers, televisions, and other devices. Surge protectors work by diverting excess voltage away from the protected equipment. They typically have multiple outlets and can protect several devices at once. When selecting a surge protector, look for one with a high surge suppression rating. This rating indicates the amount of energy the surge protector can absorb before it fails. It is also important to choose a surge protector that is listed by a recognized testing laboratory such as UL. Surge protectors should be replaced periodically as their surge suppression capability can degrade over time. It is recommended to replace surge protectors every 2 years or more frequently if they have experienced a significant surge. Proper grounding is another essential aspect of electrical safety. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing an electrical shock. All electrical outlets and equipment should be properly grounded. The grounding system should be inspected periodically to ensure it is functioning correctly. If you have any concerns about the grounding of your electrical system, consult a qualified electrician. Aluminum wiring was used in some homes built in the 1960s and 1970s. Aluminum wiring can be a fire hazard if it is not properly installed and maintained. The main problem with aluminum wiring is that it expands and contracts more than copper wiring when heated and cooled. This can cause the connections to loosen over time, leading to overheating and fire. If you have aluminum wiring in your home, it is important to have it inspected by a qualified electrician. The electrician can assess the condition of the wiring and recommend appropriate repairs or replacements. Options for addressing aluminum wiring include replacing it with copper wiring, installing special connectors that are designed for use with aluminum wiring, or applying a sealant to the connections to prevent them from loosening. Electrical codes and safety standards are constantly evolving to address new technologies and hazards. It is important to stay informed about the latest electrical safety requirements and to ensure that your home's electrical system is up to code. Consult a qualified electrician for guidance on electrical safety matters and to ensure that your home is protected from electrical hazards. Remember, electrical safety is a shared responsibility. By taking proactive steps to protect your home and family from electrical hazards, you can help prevent fires and electrical shocks. The information provided here is intended for general educational purposes only and should not be considered a substitute for professional electrical advice. Always consult a qualified electrician for any electrical work or safety concerns. The NEC is a living document, constantly updated to reflect the latest safety practices and technological advancements. The current version of the NEC is typically adopted by states and local jurisdictions after a period of review and amendment. It is crucial to consult the specific electrical codes in effect in your area to ensure compliance. The NEC provides detailed requirements for various aspects of electrical installations, including conductor sizing, overcurrent protection, grounding, and wiring methods. It also addresses specific requirements for different types of occupancies, such as residential, commercial, and industrial buildings. Understanding the NEC is essential for anyone involved in electrical work, from electricians and contractors to inspectors and engineers. The NEC also includes requirements for special equipment and systems such as fire alarm systems, emergency lighting, and renewable energy systems. These requirements are designed to ensure the safe and reliable operation of these systems. The NEC is not intended to be a design manual, but it provides a framework for the safe and proper installation of electrical systems. It is up to the designer to determine the specific requirements for each installation based on the NEC and other applicable standards. The NEC is a valuable resource for anyone involved in electrical work, but it is important to remember that it is not a substitute for professional training and experience. Electrical work can be dangerous, and it is always best to hire a qualified electrician to perform any electrical installations or repairs. The NEC also includes requirements for electrical safety in the workplace. These requirements are designed to protect workers from electrical hazards such as shock, electrocution, and arc flash. Employers are required to provide training to their employees on electrical safety procedures and to ensure that they are using proper safety equipment. The NEC is a comprehensive document that covers a wide range of electrical safety topics. It is an essential resource for anyone involved in electrical work, and it is important to stay informed about the latest updates and changes to the code. Grounding is a critical aspect of electrical safety, ensuring a safe path for fault currents to return to the source, thereby minimizing the risk of electrical shock and equipment damage. Proper grounding involves connecting all metallic parts of an electrical system to a common grounding electrode, typically a ground rod or a metal water pipe. The size of the grounding conductor must be adequate to handle the potential fault current. The NEC provides specific requirements for grounding electrode systems, grounding conductors, and equipment grounding. A properly grounded electrical system provides a low impedance path for fault currents, allowing overcurrent protection devices, such as circuit breakers and fuses, to quickly trip and interrupt the flow of electricity during a fault condition. This helps to prevent electrical shock and minimize damage to equipment. Ground fault circuit interrupters, or GFCIs, provide an additional layer of protection against electrical shock by detecting small imbalances in current and quickly interrupting the circuit. GFCIs are typically required in areas where water is present, such as bathrooms, kitchens, and outdoor outlets. Bonding is another important aspect of electrical safety, which involves connecting all metallic parts of an electrical system together to create a continuous electrical path. Bonding helps to equalize the voltage potential between different metallic parts, reducing the risk of electrical shock. The NEC provides specific requirements for bonding different types of metallic equipment, such as pipes, conduits, and enclosures. Surge protection devices, or SPDs, are used to protect electrical equipment from voltage surges caused by lightning strikes, power outages, or other electrical disturbances. SPD divert excess voltage away from the protected equipment, preventing damage to sensitive electronic components. The NEC provides requirements for the installation and use of SPD. Electrical inspections are an important part of ensuring the safety of electrical installations. Electrical inspectors review electrical plans and inspect electrical work to ensure compliance with the NEC and other applicable codes. Electrical inspections are typically required for new construction, renovations, and repairs. Arc flash is a dangerous electrical hazard that can occur when a short circuit or other electrical fault creates an arc of electricity. Arc flash can cause severe burns, blindness, and even death. The NEC provides requirements for arc flash hazard assessment, personal protective equipment, and safe work practices. Electrical safety training is essential for anyone who works with electricity. Electrical safety training should cover topics such as electrical hazards, safe work practices, personal protective equipment, and emergency procedures. Qualified electrical workers should receive regular training to maintain their skills and knowledge. Lockout/tagout procedures are used to prevent accidental energization of electrical equipment during maintenance or repair. Lockout/tagout procedures involve disconnecting the power supply to the equipment and attaching a lock and tag to the disconnect switch to prevent it from being turned back on. The NEC provides requirements for lockout/tagout procedures. The electrical safety audits are used to identify potential electrical hazards and to assess the effectiveness of electrical safety programs. Electrical safety audits should be conducted regularly by qualified personnel. Portable generators can provide temporary power during power outages, but they can also be a source of electrical hazards. Portable generators should be used in a well-ventilated area to prevent carbon monoxide poisoning. They should also be properly grounded and connected to the electrical system using a transfer switch to prevent backfeeding. Backfeeding occurs when electricity from the generator flows back into the power grid, which can be dangerous for utility workers. The NEC provides requirements for the safe installation and use of portable generators. Renewable energy systems, such as solar photovoltaic systems and wind turbines, are becoming increasingly popular. NEC provides requirements for the safe installation and operation of renewable energy systems. These requirements cover topics such as grounding, overcurrent protection, and disconnects. Electrical safety is a shared responsibility. By following safe work practices, using proper safety equipment, and staying informed about the latest electrical safety requirements, we can all help to prevent electrical accidents and injuries. Remember, if you are not qualified to perform electrical work, always hire a qualified electrician. Electrical work can be dangerous, and it is always best to leave it to the professionals. By understanding the NEC, practicing safe electrical work habits, and using appropriate safety equipment, individuals can significantly minimize the risks associated with electricity and contribute to a safer environment for themselves and others. The principles of electrical safety are universal and applicable in various settings, from residential homes to industrial facilities. Continuous learning and adherence to established safety protocols are paramount for preventing electrical accidents and ensuring the well-being of individuals working with or around electricity.